here, just different modulation scheme. Okay, so it's M1 and M2, and this will be multiplied by, let's say, a cosine, and this will be multiplied by a sine. Okay, notice that here, or I can just write them here to. So cosine 2 pi fct, and then they usually show that this is shift by pi over 2, and unsurprisingly, this is the Hilbert transform. In MATLAB, you don't have to Hilbert transform this cosine into a sine, okay? You can just write a sine wave. And this would be multiplied by m2 of t, okay? And this is just the sine 2 pi fct, right? That is being multiplied by this one, okay? So in here, we call this branch, we broadcast it. We call this branch the in phase. We call this branch the quadrature. So when we refer to the in phase branch, it's always on the cosine. It's always the one in the. It's always the one with the real value. And when we refer to like the quadrature, it's always the one with the.
Stop.
What is? Hello. What is that? Who's speaking?
Dewey, mic check.
Sorry, I was yelling at my dog.
Well, okay. All right. So here, when we have the in phase, that means it's always real, or we call it the in phase. The in phase, and the imaginary is the quadrature. Okay, so sine being the imaginary function belongs to this branch, the quadrature, and this is real. And you might be wondering, if we send these two, why won't it get canceled, or why won't it get like interference? Well, these two are orthogonal to each other. You see that? So this is orthogonal, meaning it's like 90 degrees off from each other. So then when we multiply, we don't just multiply it, okay? When we multiply in this sense for interference, we do inner product. Inner product, if you have studied vector calculus before, you should know what inner product means, and that just means that a sine and cosine the multiplication will be 0, because it's the inner product. Sorry, the inner product will be 0, and there will be no interference because of the orthogonal nature of it. Okay. All right. So that's it. So now next thing we're gonna do is add these two together. Okay. So add these two together, and there's the broadcast. There's the channel. But I don't know. I'm not gonna say anything about this. Just know that it's being broadcast, and there's nothing to simulate over here because we're not dealing with noise or channel or anything. Right? And then we have the receiver, which divided into branch, and this divided into branch is nothing. It's just that one summation signal, and it's split into two, and you don't have to do anything about it. It's the same signal. Like some students before think that this split must mean that in coding we have to do something with it to split it, but it's really not. It's really just this one signal multiplied with this, and this one's again this same signal multiplied with that one. All right. So, and this will be again multiplied with the cosine branch. Same thing as here. It will be the same as this one, and this will be multiplied by the sine branch, which is the same thing as this one. And then when you get the result, you do low pass filter to get the baseband. Right? Same thing as with lab 2. And then for the demodulated signal, you should get something close to that. So Again, I was using M1 of t because these two are technically not the same because of the filter. So it's M hat of t and 2 hat of t. M1's hat of t will be equal to M1 of t only if the low pass filter is ideal. But our filters can never be ideal for that. Okay. Any questions concerning this? No questions? All right. You guys are good to go for this lab. All right. Are you guys noting these downs?
Yep.
Okay.
I have a question.
Yes.
So when do we demo for lab 2?
I don't think demo is necessary. Did Dr. Kwan say anything about demoing lab 2? Because I find it impossible to like do it.
So we're just presenting the part 4. We're just including that in our code in our, what do you call that, our lab report, and that's it, and we turn it in.
Yeah.
Okay. Just asking.
So did Dr. Kwan say anything about demoing something?
No, I don't think so.
If in class, then yes, we do have demo. You do it and then you explain to me what happened. I go to your table and then you demo it to me. But online here, I don't think there's a suitable way to demo that.
Okay.
Ask question, and yeah, if you do it online, it would take up a lot of time because I have to do like one by one online, and then I have to like do it privately. I can't just squirt it out into the public.
That sounds good. Thank you.
Yeah. All right, so I'll end this.